Hello everyone, and welcome. Today, we're diving into the world of a very important chemical, potassium hydroxide, or KOH. You might know it as a strong base, but what does it actually do in organic chemistry? It turns out, KOH is a super versatile reagent with two main personalities. It can act as a powerful base, and it can also be a strong nucleophile. Understanding these two roles is key to predicting how it will react. So, let's break down the major jobs of KOH. First, let's talk about KOH as a strong base. Its main job as a base is to snatch a proton. This is super important in elimination reactions, specifically a process called dehydrohalogenation. Imagine you have an alkyl halide, like 2-bromopropane. If you react this with KOH dissolved in alcohol, like ethanol, something cool happens. This is often called alcoholic KOH. The hydroxide ion from KOH pulls off a hydrogen from one carbon, while the bromide leaves from the adjacent carbon. The result? The two carbons form a double bond. We've just made an alkene, in this case, propene. The solvent is crucial here. Using an alcohol as the solvent pushes the reaction towards elimination. Remember, alcoholic KOH gives you an alkene. Now, let's look at KOH's other personality, a strong nucleophile. The hydroxide ion, OH-, is rich in electrons and loves to attack positively charged or electron-poor centers. What happens if we take an alkyl halide but this time use aqueous KOH, which is KOH dissolved in water? The game changes completely. Instead of elimination, we get a substitution reaction. The hydroxide ion attacks the carbon atom bonded to the halogen, kicking the halogen out. For a primary alkyl halide like bromoethane, this SN2 reaction works beautifully. The bromine is replaced by the OH group, and you form an alcohol, in this case, ethanol. So, the solvent is the director of the play. Alcoholic KOH for elimination, aqueous KOH for substitution. But wait, there's more! KOH has another famous role, saponification. This is just a fancy name for the base-catalyzed hydrolysis of an ester. Esters are compounds that often give fruits their pleasant smells. If you heat an ester with KOH, the hydroxide ion attacks the carbonyl carbon of the ester. This breaks the ester apart. You end up with an alcohol and the potassium salt of a carboxylic acid. And this product, the potassium carboxylate, is actually soap. This is literally how soap is made. Using potassium hydroxide gives you a softer, more liquid soap compared to the hard bar soaps made with sodium hydroxide. So, to recap, potassium hydroxide is a powerhouse in organic chemistry. It can act as a base with an alcoholic solvent to create alkenes through elimination. It can act as a nucleophile with an aqueous solvent to create alcohols through substitution. And it's essential for saponification, breaking down esters to make soap. It's a fantastic example of how changing one condition, like the solvent, can completely change the outcome of a reaction. Thank you so much for watching. If you found this video helpful, please give it a thumbs up, subscribe for more chemistry content, and leave a comment below with any questions or suggestions. Your support helps the channel grow. See you in the next video.